So we've got here the binding energies, the electron level energies, for the hydrogen atom. So when an electron's in the ground state, it sits down here, and the first shell above that is up here, second excited state, third excited state, etc., etc. And all the way up here is how much energy it needs to get 13.6 electron volts to release or pull that electron right off the hydrogen atom. And the photon of wavelength 478 nanometers, meters, is emitted from an excited hydrogen atom. The emerging photon is a transition between two of those states. Draw an arrow. On figure 6 it shows that from the initial to the final state. We're going to do some working to get here. So they've given us the wavelength. We want to put that into energy because they've given us electron volts. We want to go, how does wavelength turn into energy? And the formula we use is hc over lambda. If we use the 6.63 by 10 to the minus 34 number for h, for Planck's constant, by 3 by 10 to the 8, all over 478 nanometers, we get 4.16 by 10 to the minus 19 joules. So using this, Planck's constant gives us joules, and then we have to turn it to electron volts by dividing by 1.6 by 10 to the minus 19, and that gives us 2.6 electron volts. If we were to do the same formula but use the other Planck's constant, we'd get 4.13 by 10 to the minus 15. The speed of light's still the same, c, 3 by 10 to the 8. Wavelength's still the same, 478 by 10 to the minus 9. And that gives straight away to the 2.6 electron volts. So we've got the same answer in both cases. So the photon of light that's given off is because the electrons jump from one of these to another one. 6 to 4, 6 to 5, maybe 6 to 2, maybe 6 to 1, maybe 2 to 1. But the energy of the photon we've got is 2.6 electron volts. So we've got to look and say, where is the gap here, 2.6 electron volts? Well, if it ended up here and it came from anywhere else, the gap's going to be bigger than 10.2. So it didn't end up here. The gap between here and 12.1, that's 1.9. The gap between here and here is 0.7. And the gap's getting smaller and smaller up here. The gap 2.6 is actually between here and here. 12.8 minus 10.2 is 2.6. Okay, cool. We've got the gap. So now do we draw our arrow as up, or do we draw our arrow as down? If it was up, it's because a photon's been absorbed. And if it was down, it's because the photon is being emitted. Now in this case, a photon is emitted. Right. So we're drawing our arrow from here to here, and it's down.